Oh, hey, didn't see you there. Are you new to the team? Okay, well, hop on in. I'll show you how to get faster at swimming. So how can you get faster? It's all up to Bernoulli's equation. But first, let me explain what drafting is. So this is a pool, and this is a person. This person is not drafting. In this pool, there's two people, but person A is drafting. So drafting is basically using the bubbles behind the other person to help give you a little push in your swim. According to triathlete.com, swimming behind another athlete can save you upwards of 30% energy expenditure. In such an endurance-based sport like triathlon, that is a big difference. So let's go to Mac, and I'll show you a little bit more about Bernoulli's equation. So let's talk about Bernoulli. Not the guy, but the equation. So this is his principle right here, up here. The P's that don't have ones or twos stand for density. The G's, obviously gravity. Pressure and velocity is also factored into these. And you can also consider the height if that matters. So, and change of altitude. But for the example problem that I'm going to show you, we're not going to consider that. So, higher pressure, lower speed. So, bigger width or diameter into a smaller diameter tube would mean lower pressure and higher speed. So, this can be applied to this problem right here that I based off a problem by the organic chemistry tutor. So, two swimmers work together to swim along Hawaii's Waikiki Beach. Assume there are no waves. The waves generated by swimmer A have a cross-sectional area of 4 meters squared. The waves flow around swimmer B at a pressure of 10,132.5 pascals with a cross-sectional area of 2 meters squared. Swimmer A is paddling through at a pace of 0.83 meters per second. What is the water's pressure at swimmer B? So I now understand that this might have been kind of confusing. I mean like no external ways. So anyways, the first step I did was I wrote down Bernoulli's equation. And since the height does not change in this problem, we're just going to cancel out these two. And then I put down all my knowns. So I know the pressure at swimmer B, I know the velocity of swimmer A, and I know the density. I looked it up through a table. And then using these areas that I have that kind of form like the pipe shape, I can figure out the velocity of swimmer B. So I did that right here. So I plugged them all into the equation, and then I solved for pressure at A. So this makes sense because the swimmer A, as you can see, they have a wider pipe, has a higher pressure than swimmer B right here. And also, swimmer B has a higher velocity than swimmer A. So as you can see, velocity and pressure are inversely related according to this equation.